What's up guys, and welcome to this video tutorial / walkthrough on question 9 of the 2016 supplementary exam. This question is on the photons and electrons and is worth 14 marks. Okay, so question 1 is a definition. So describe the photoelectric effect. Okay, so it is a process that occurs when light of a sufficient energy shines on a metal and electrons are ejected. You could say from the surface. Okay, but we get 2 marks for that. Okay, question 9.2. Okay, says an energy level diagram for a particular element is drawn to scale. In the diagram below, the only possible outer electrons can occupy are the energy levels E1, E2, and E3. How many spectral lines are possible for this emission? Okay, there's 3 energy levels, so there are 3 possible spectral lines, and we get 2 marks for that. 9.2.2, which transition would release energy with the highest frequency? Okay, so remember, if we look at our formula sheet, we can see that energy is equal to H times F. Okay, so we can say that the change in energy is equal to HF, right? So the frequency equals change in energy over H, which is a constant. Okay, change in E over H. Okay, so this is change in E1, and this is change in E2, and this would be change in E3. So we're looking for the highest change in energy level, which would be the change in energy 3, okay? Because change in E3 equals change in E1 plus change in E2, okay? So the highest change, highest frequency comes out when there's the highest change in energy. So that would be from energy level 3 to E1. Okay. Then, so that's, for that we get 2 marks as well. Okay, so for this energy level diagram, the longest wavelength possible. Okay, so the longest wavelength, okay, so we can also use the equation change in E equals, let's see, it's HC over lambda, HC over lambda wavelength, right? So the longest wavelength occurs, the longest wavelength, okay, so lambda equals HC, both of these are constants, it's Planck's constant and the speed of light over change in E. Okay, so the longest wavelength occurs for the smallest change in energy, which would be change in energy 1, okay? So this corresponds to change in E1. Okay, so the longest wavelength is 618 times 10 to the minus 9 meters. On the diagram, show the transition for this wavelength. Okay, so we already discussed this, so this is that transition. Okay, so the diagram would be this diagram right here. Okay, and we get 2 marks. Okay, so calculate the energy in joules that corresponds to this wavelength. Okay, so 9.2.4, we can use the equation E equals HC over lambda, which is our wavelength. Okay, so we're looking for the energy. E equals, okay, so Planck's constant is 6,6 times 10 to the minus 34. C is speed of light, which is 3 times 10 to the 8, over lambda, which is 618 times 10 to the minus 9. Okay, so we get that E is equal to 3,2 times 10 to the minus 19 units of joules. And we get 4 marks for that. Quite generous. Okay, explain why a transition between energy levels produces an emission line. Okay, so basically, this is a theory question as well. So it's basically because electrons can't process any more energy, than allowed in the energy line when they move. So when they move to a lower energy level, the difference in energy between the levels has to be discarded, or the energy has to be released. Okay, so because so that's the reason. Let me say that again. So electrons can't possess any more energy than allowed in an energy level. So when they move to a lower energy level, the difference in the energy between the levels has to be emitted or discarded. Okay, so I hope that makes sense. That's also basically a definition theory question worth 2 marks. Okay, and that's and the end of the paper. So cool stuff. Next time we will do a different paper. Yeah, thanks for watching, and I hope you found this useful.